Hello, Precalculus. So we are going to be working on part of 5.5 today. So this is going to be our double angle identities. So we have new formulas. Of course, these formulas will be given to you on your unit circle. I will make you guys a new one for the test, and I will pass out a new one when I can. But these will, of course, be on your unit circle. So you don't need to know them. You just need to know how to use them. So let's start with our first example. It says if tangent theta is equal to rad 2 over 4 and theta is in between pi and 3 pi over 2, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So the first thing that we need to figure out, this first part is just like what we've already been doing. So just like what we've done in the past, we need to figure out what quadrant this is in. So to do that, we look at that, like, where's theta in between? So we look here. And so what I'm going to do is I'm just going to go to my unit circle and look to see where on my unit circle do I see pi to 3 pi over 2. So pi to 3 pi over 2 is in quadrant 3. So what that's telling me is that this angle is in quadrant 3. Okay, so we're going to start there. And I'm just going to start by drawing my triangle. Okay, so we have our triangle. We know we always go back to the x-axis. My theta is always at the origin, and then we can start to label the parts that are given. So it tells us that tangent theta is equal to rad 2 over 4. So we know tangent is the opposite over the adjacent. And so if I label my triangle here, this is my opposite, my adjacent, and my hypotenuse. And so that tells me that this part is rad 2, and then this part is 4. Now I need to be careful here because I need to think about my positives and negatives. So we know that in quadrant 3, tangent is positive. And the reason tangent is positive there is because it's always going to be a negative value over a negative value. And so if we think about it, this is a negative 4 because it's in the negative x direction. And this is a negative rad 2 because, again, that's in the negative y direction. So I'm just going to make a quick note of that. So those are going to be, so both values are negative. Because they are in the negative direction on the graph. So we still are always thinking about, okay, this is a negative x, this is a negative y. That's why it's really telling us the quadrants. Okay, so the last thing we have to do is just find our missing side length. So it's our hypotenuse. So that means it's going to be leg squared plus leg squared equals hypotenuse squared. So that's going to be negative rad 2 squared plus negative 4 squared equals x squared. Now, when I square a radical, so for 1, the negative, of course, goes away. It makes it positive. And then when I square the square root, that goes away, and I'm just left with a regular 2. And then when I square 4, so negative 4 squared is 16. And then I get 2 plus 16, so I get 18 equals x squared. Now, when I take the square root of that, unfortunately, this ends up to be kind of an ugly radical. This is the one I'm doing with you. So, we've got to do some ugly radicals at sometimes. So I'm thinking, okay, what's a perfect square that goes evenly into 18? And that's going to be 9 times 2. So that tells me, okay, I know the square root of 9 is 3. I don't know the square root of 2, so it's going to be 3 rad 2. My hypotenuse is always positive, so that's going to be a positive 3 rad 2. Okay, so from there, I'm just going to kind of figure out what my two other trig functions are. I have tangent, but to find like sine of 2 theta, cosine of 2 theta, we clearly need sine, cosine, and then we're going to use tangent as well. So I'm just going to write out, okay, so let's start with finding sine theta. So sine theta is going to be the opposite over the hypotenuse. So negative rad 2 over 3 rad 2. Now, a lot of ugly radicals there, but hopefully we recognize, okay, what's on top and what's on bottom. Is there anything the same? And there is. They both have a radical 2, top and bottom, and so those will cancel out. And so my final answer here, sine theta, is going to be equal to negative 1/3. So there you have it. So let's move on to cosine. So cosine theta, I think I can squeeze it in here, is going to be equal to the adjacent over the hypotenuse. So negative 4 over 3 rad 2. So with this one, unfortunately, the radicals don't cancel out on top and bottom, but I do have to rationalize my denominator. So I'm going to multiply top and bottom by the square root of 2. Really squeezing it in there. And I get negative 4 rad 2 over, okay, so rad 2 times rad 2 is 2, and then 2 times 3 is 6. Now, I look to see, is there anything I can simplify there? And I can. The 4 and the 6 are both divisible by 2, so I can simplify that to be negative 2 on top and positive 3 on bottom. So now I have sine of theta, I have cosine theta, which is going to be equal to negative 2 rad 2 over 3. And then we were given tangent theta. So tangent theta is equal to rad 2 over 4. So we are going to use this information to help us to solve all the other ones. Okay, so we're now going to just start. Unfortunately, that was just kind of the base work for finding out everything else. So now that we found all of our singular trig functions, now we can start to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So let's start with sine of 2 theta. So that's going to be using the formula above. So it's going to be 2 times sine theta times cosine theta. And so I just am simply going to plug in what I have. So 2 stays as is. Sine theta we figured out was negative 1/3. And cosine theta was negative 2 rad 2 over 3. And so when I'm multiplying, you can think of that as 2 over 1. You're just multiplying the tops together and you're multiplying the bottoms together. So 2 times negative 1 times negative 2 rad 2. Well, 2 times negative 1 is negative 2. And then negative 2 times negative 2 gets me a positive 4. And then the rad 2 stays the same. And then 1 times 3 just gets me 9. Nothing I can do to simplify. So my final answer for sine of 2 theta is 4 rad 2 over 9. And that's it. So we are done. Okay, so let's move on to cosine of 2 theta. So if you notice, cosine of 2 theta has a lot of different formulas there. It really doesn't matter which one you use. You can use any of those 3 formulas. It's just a matter of which one kind of makes the most sense. Now, even if one doesn't make more sense than the other, it really doesn't matter. Like I said, all of them will get you to the right answer. Like all of them will get you to the same answer. So let's kind of decide which one we are going to use. So I look at my trig functions, what I have sine as -1/3, cosine as -2 rad 2. I'm going to focus it. I feel like it's a little blurry. I feel like that helped. Okay. And then tangent is rad 2/4. So I'm looking up here and I'm thinking, okay, cosine and sine. This one only uses sine. This one only uses cosine. And looking at my like trig functions, sine is really basic. Cosine, not as basic. And so I'm thinking, why don't I just use the one that just has sine? So I'm going to do 1 minus 2 sine squared theta. Again, you don't have to use that one. You can really use any of the formulas and you should be able to get the same answer. Great way to check your work. So you can use any of the cosine 2 theta formulas and you should still get the right answer or still get the same answer. Still get the same answer. Okay, so let's just plug that in. So that would be 1 minus 2 times sine -1/3 squared. So remember the squared goes on the outside. Now you have to remember PEMDAS when you're doing this. So when you're doing this, you have to think about your order of operations. I do my exponents first. So I'm first going to do -1/3 squared. So -1/3 squared is going to get me a positive 1/9. And then, okay, so we do exponents and then we multiply. So I'm going to multiply 2 times 1/9. Remember, that's 2/1. So that would be 1 minus 2/9. And now I can add or subtract. So you can do that in your calculator. I can just go in and go, okay, what's 1 minus 2/9? I can get a common denominator. The common denominator there would be, or well, let's math frac that. So it would be 7/9. The common denominator would be 9/9. 9 minus 2 is 7. You get 7/9 either way. So that means that cosine of 2 theta is equal to 7/9. And that's my final answer. Okay, so now our last one is to do tangent 2 theta. So tangent 2 theta, of course, it's division. So I'm going to rewrite that as like the two separate parts. If that doesn't make more sense to you, then leave it like one on top of the other. Either way, you should get to the same place. Okay, so tangent 2 theta is equal to 2 times tangent theta divided by 1 minus tangent squared theta. And I'm just going to put those in parentheses so we don't get confused. Okay, so 2 times tangent theta. So that's going to be 2 times rad 2/4 divided by 1 minus tangent squared theta. So rad 2/4 squared. So right now I'm just going to deal with it kind of part by part, and then we'll put it all together. So first thing I recognize is over here, I can simplify the 2 and the 4. That would be 1 and 2. So that gives me rad 2/2. Now with this one, I'm first going to square this. So that would get me, I'm going to kind of do this on this side. So rad 2/4 squared would get me 2/16 because you square both top and bottom. And so the square of a square root gets rid of it. So it's 2. And then 4 squared is 16. And then we can simplify that. So 2/16 simplifies to be 1/8. So we have 1 minus 1/8. Now, remember, before you can flip and multiply, you have to have a singular fraction on the left and then a singular fraction on the right. We already have a singular fraction here. We just need to get a singular fraction on the right side. So you can either do that in your calculator or get a common denominator. Common denominator would be 8. It would be 8 over 8 minus 1 over 8 would get you 7/8. Or just do that in your calculator. 1 minus 1 over 8, math frac, and then it gets us 7/8. So I have rad 2 over 2 divided by 7 over 8. Now that I have a singular fraction on the left and a singular fraction on the right, I can flip and multiply. So I have rad 2 over 2 times 8 over 7. I can simplify what I can. The 8 and the 2 are both divisible by 2. And so my final answer is going to be 4 rad 2 over 7. So I'll write that on the side here. So tangent 2 theta equals 4 rad 2 over 7. So it's a lot of fractions. Of course, this one's more challenging because we have the radicals in it. 2 is a lot less challenging because there's no radicals involved. But again, it's just understanding how to use the formulas, when to use what formula, and applying it correctly. So the more work you show, the better it's going to be for you. Okay, so let's look at 2. So looking at 2 starts off the same. If you want to try 2 on your own and kind of check back in, I think that would be great. If we were in class, that is exactly what I would be having you guys do right now, is kind of just do parts by parts and check back in. I will go through the whole process, but if you want to, try it on your own, this is a good time to pause and try it on your own. Okay. So if we're looking at 2, it says if cosine theta equals 8 over 17 and theta is in between 3 pi over 2 and 2 pi, find all of the others. So of course, we're first looking here and figuring out what quadrant is that in. So I go to my unit circle and I look, okay, where is 3 pi over 2 to 2 pi? And that's where it is. And so this is telling me, okay, that's quadrant 4. Okay, so now that we know it's in quadrant 4, we're going to draw our triangle. Again, always going back to the x-axis from the origin. And so it's giving us cosine theta equals 8 over 17. We know cosine is adjacent over hypotenuse. So adjacent over hypotenuse. I'm just going to label the parts of my triangle. So this is the adjacent, the opposite, the hypotenuse. So the adjacent is 8, the hypotenuse is 17. So again, I'm still thinking about my signs. The hypotenuse is always positive. We know that. The adjacent, this is a positive x direction, but this is going to be a negative y direction. So this is going to be a negative value. So we need to find our missing side length to be able to finish the rest of this. So we have a leg, we're missing a leg, and we have the hypotenuse. So it's going to be 8 squared plus x squared, the missing leg, is equal to 17 squared. So all I'm going to do in my calculator is I'm just going to do 17 squared minus 8 squared, and I get 225. So I get x squared equals 225. Take the square root of both sides, and I get x equals 15. Again, we recognize that this is going to be a negative 15 because it's a negative y value. Now, like I said, this one's a lot easier because there's no radicals, so I can just now write down my 3 trig functions. So I have sine theta is going to be opposite over hypotenuse, so negative 15 over 17. I have cosine theta, which was already given to us, 8 over 17. And then I have tangent theta, which is going to be the opposite over the adjacent, so negative 15 over 8. So these are the three values that I'm going to use to find the rest of my sine 2 theta, cosine 2 theta, and tangent 2 theta. So again, if you wanted to just like check in here, this is a great place to kind of now try your own using the formulas and plug those values in. Again, I'm going to still go through these. Okay, so let's start with sine of 2 theta. I'm just using the formula from up above, so that's going to be 2 sine theta times cosine theta. So that's going to be 2. Sine theta is going to be negative 15 over 17, and cosine theta is going to be 8 over 17. So I just multiply top to top, bottom to bottom. So it's going to be, and all I really do is like in my calculator, 2 times negative 15 times 8 gets me negative 240. And then 17 times 17 gets me 289. If you can reduce that, I'd want you to. Remember, you can check that in your calculator. You can just go negative 240 divided by 289, math frac, and it will give you the reduced answer. Now, this is the reduced, negative 240 over 289. So that would be my final answer. Okay, so that is the sine of 2 theta. And then let's move on to cosine. So cosine 2 theta, you can use any of your formulas. Again, it doesn't matter what formula you use. There's no preference here. So I'm going to actually use cosine squared theta minus sine squared theta because both of my sines and cosines are pretty easy, but it doesn't matter. So I'm going to use cosine squared theta. If you used a different one, you should still get to the same answer. Okay, so we're going to square 8 over 17. Then we're going to square negative 15 over 17. So I'm going to do that in my calculator. That's going to be 64 over 17 squared, which is 289, minus 15 squared, which is 225. The negative goes away because you're squaring a negative times a negative, and then 289. They already have a common denominator, so we just subtract the tops. 64 minus 225 gets me negative 161. Of course, check to make sure in your calculator, negative 161 over 289, does that reduce? And it doesn't. That's my final answer. Okay, and then the last one is going to be tangent of 2 theta. So tangent of 2 theta, again, I'm just going to kind of write it out as division like I did up above. So that's going to be 2 tangent theta divided by 1 minus tangent squared theta. So, was my face in there? That's awkward. I'm so sorry if you're seeing my nose when we're doing this. Anyways, so that's going to be 2 times tangent, so negative 15 over 8, divided by 1 minus negative 15 over 8 squared. So again, I'm just going to kind of do part by part. So first thing I would do is simplify the 2 and the 8. That would get me a 1 and a 4. So that's going to be negative 15 over 4. You know what? I'm going to move this over here. And then divided by, that's going to be 1 minus 15 squared, which is 225, over 8 squared, which is 64. Remember, we have to do our exponent so that negative goes away, and then the minus stays there. Now you can do that in your calculator. You can get a common denominator. That would be 64 over 64, and 64 minus 225 is negative 161. Or again, you can just go 1 minus 225 over 64, math frac, negative 161 over 64. So then I have divided by negative 161 over 64. I need to flip and multiply, so that would be negative 15 over 4 times 64 over negative 161. You can either just put that in your calculator and reduce it, like let the calculator do the reducing for you, or you can reduce it yourself. 4 goes into 64 16 times, and then negative 15 times 16 is negative 240 over negative 161. Those would both become positive. So my answer is 240 over 161. So of course, tangent is still a pain, but your calculator hopefully makes it a little bit easier. And that's that. Okay, so we're going to move on to the second page of notes. So I'm going to turn the page. The nice thing about the video is if you're not done, you can pause me and keep going. But we're going to go on to the second page, which thank goodness I have right here. Okay, so I'm going to keep this here because we are going to be using our formulas still. So now what we're going to be doing is we are going to be solving our equations using double angle identities. So if you don't already have your unit circle out, get your unit circle out. You're going to need it. Okay, so I look at 3 and it looks terrible, but it's actually not that bad, I promise. So I look and I see, okay, I have sine of 2x, so that's one of my double angle identities, plus 4 cosine x equals 3 cosine x. So the first thing I recognize is that I have a bunch of cosines and then a sine 2x. So the first thing I'm going to do is I'm going to rewrite that one using singular sine and cosine. And so that's using my formula. So I am going to use the formula sine of 2 theta equals 2 sine theta times cosine theta. And so I'm going to replace this with this whole thing because I want those singular trig functions, not the like 2, because we don't have that on our unit circle. Those aren't points. So, okay, so in place of sine 2x, I'm going to write 2 sine x times cosine x. And then the rest I'm just going to bring down. So plus 4 cosine x equals 3 cosine x. Now, at this point, okay, it still looks like a lot, but whenever we're solving, my first thought whenever I'm trying to solve like a trig equation is to move everything to one side. So this 3 cosine x, I'm going to move to the other side. Now this is a cosine x. This is its like term, right? Because they both have a cosine x. So I can combine those. So I have 2 sine x, cosine x, plus 4 minus 3 is 1. And so that's just cosine x equals 0. So remember, we're trying to essentially isolate our trig functions so we can solve. So I'm looking at my two terms, 2 sine x cosine x plus cosine x. And I'm thinking, do they have anything in common between 2 sine x cosine x plus cosine x? They both have a cosine x. So I'm going to factor out my GCF. So that's going to be cosine x. And then what's left inside. So when I factor out a cosine x from 2 sine x cosine x, I'm left with 2 sine x plus 1 equals 0. Now, if you're having a hard time seeing that, seeing the like GCF and how to factor that out, you can think about it in terms of like x's and y's. So if I have 2x, x being sine, y plus y, y being cosine. Both of these terms have a y term we can factor out, and I'd be left with 2x plus 1. It's the same here. It's just, bigger things, sine x and cosine x. So it's the same idea. Okay, so now that it's totally factored, there's nothing more I can do. I can set each factor equal to 0 and start to solve. So I have cosine x equals 0. That's done. That's solved for. And then I have 2 sine x plus 1 equals 0. So then this one, I just got to get sine x by itself. So I'm going to subtract 1, divide by 2, and I get negative 1/2. So I have two things. Now is when I need to go to my unit circle. And again, I'm thinking, So I'm thinking on this one, okay, where on the unit circle does the x value, because cosine is the x value, where on the unit circle does the x value equal 0? So we go to our unit circle. I'm looking at all of my x values. There's 1 pi over 2, and then 3 pi over 2 is another one. So pi over 2 and 3 pi over 2. Okay, so then I move on to sine x. So where does sine is my y value? Where does my y value on the unit circle equal negative 1/2? So I go again and start looking at my y values. Positives, okay, 7 pi over 6, and then also 11 pi over 6. So 7 pi over 6 and 11 pi over 6. And those are my answers. So x is going to be equal to pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. And that's that. So using our identities to help us to simplify and solve is another aspect of this. If you guys want to pause me here and try 4 on your own, 4 is very similar to 3, like almost identical. But I'm going to go ahead and do that one with you. So again, if you want to try it on your own, pause me here, try it, and come back and check your work. But I'm going to go ahead and start that one. So again, I see one of my double angle identities. I'm going to use the formula. I'm just going to, again, write it on the side. So that's sine of 2 theta is equal to 2 sine theta times cosine theta. Again, I'm just using the formula from up above. So I'm going to plug in, okay, so sine of 2x. And then I'm going to replace it with the singular values. So it's going to be 2 sine x cosine x minus sine x equals 0. Okay, so now I have everything on one side. So that step that I did up above, I don't need to do. So now I'm just thinking, okay, is there anything I can factor out? So between 2 sine x cosine x and minus sine x, they both have a GCF of sine x. So I can factor that out. That would be sine x. And then I'm left with 2 cosine x minus 1. And then just like up above, now that it's completely factored, I can set each factor equal to 0 and solve. So I have sine x equals 0, 2 cosine x minus 1 equals 0. This one's already solved for. This one I need to still solve for, so I'm going to add 1, divide by 2, and I get cosine x equals 1/2. Okay, so at this point, I am now using my unit circle. So I'm thinking, where on my unit circle sine is my y value? So where does my y value equal 0? So that equals 0 at 0. Remember, we use 0, not 2 pi. And then also at pi. So 0 and pi. cosine. Cosine is looking at my x value. So where on my unit circle does my x value equal 1/2? So we have pi over 3, and then we have 5 pi over 3. So pi over 3 and 5 pi over 3. So x is equal to 0, pi over 3, and 5 pi over 3. And that is that. Okay, so let's keep going. We are almost done. Okay, so with 5, we have cosine 2x minus sine x. Now, if you guys recall, looking at all of our cosine formulas, we have a bunch of cosine formulas. So the trick here is to figure out which one to pick. So I look at my equation and I think, okay, so the one that's singular is sine x. So what I'm going to use is the one that only has sine in it. So I'm going to use, in this case, cosine 2 theta is equals to 1 minus 2 sine squared theta. So I'm just going to write that on the side here. So that would be cosine 2 theta equals, oops, I lost it there, 1 minus 2 sine squared theta. If this was a cosine, we'd use the 2 cosine squared theta minus 1. There's not a time when you're like putting it into an equation that I could imagine you'd use cosine squared theta minus sine squared theta. Okay, so I'm going to replace that. And so cosine 2x is going to become 1 minus 2 sine squared x. And then the rest is the same. Now, first thing I'm going to do is just rearrange it. So like my squared term is first, and then my x term, and then my number. So that's going to be negative 2 sine squared x minus sine x. That's a plus 1 equals 0. Now, remember what I always say about x squared terms, which this is my x squared term. We always want them to be positive. So what I would do is multiply everything through by a negative 1 so that this term is positive. So that would get me positive 2 sine squared x plus sine x minus 1 equals 0, because negative 1 times 0 is still 0. So we multiplied everything by a negative 1 because we wanted the squared term to be positive. So I'm just going to write that here. So the squared term is positive. And now I can go ahead and start to factor this. So I'm just going to kind of factor it with my x's. So I'm going to think about it over here. So that would be 2x squared plus x minus 1. Now, because a is greater than 1, my a value here is 2, I do have to split the middle term. So I'm thinking what two numbers multiply together to get me negative 2 and add to get me 1. So those two numbers, when I'm thinking about that, is going to be 2 and negative 1. So again, I have to split the middle term. So that would be 2x squared. My middle term is split between these. So plus 2x minus 1x minus 1. Remember, it doesn't matter which order you put those in. It's irrelevant. And then I can factor by grouping. So from 2x squared plus 2x, I can factor out a 2x, and I'm left with x plus 1. From negative 1x minus 1, we always bring down our middle sign. Now, there's nothing that I can factor out, but you can always factor out a 1. And then I'm left with x plus 1. Because if I factor out a negative 1, that gets me a positive x, and a negative 1 divided by a negative 1 also gets me a positive x. So then my two factors are 2x minus 1 over x plus 1. Now, before we were like transferring it over and solving, and you can still do that. But what I was thinking is, why don't we just like keep going with this and then transfer it over once it's solved? So I could keep solving this. and I get 2x minus 1, so x equals 1/2, and then x equals -1. And then I can just transfer it over and say, okay, x was my sine x, so sine x equals 1/2, and sine x equals -1. Could you also just do like 2 sine x minus 1 and then sine x plus 1 and then set both of those and solve? Totally. Did I do that before? Yes. Do I think this is maybe easier for you guys to think about? Maybe. So do it whatever makes sense. So now we're thinking about our unit circle. So where does my y value equal 1/2? And that's going to be at pi over 6 and 5 pi over 6. And then where does sine, again, my y value, equal -1? And that's only at 3 pi over 2. So for this one, I have 3 answers. I have pi over 6, 5 pi over 6, and 3 pi over 2. Okay, last one. Hallelujah. Okay, so same thing here. We have cosine 2x. So the first thing is we have to think about what formula we're going to use. So I'm looking here. This is cosine x. So between my 3 formulas, I'm going to use the only one that has just cosine by itself. So I'm going to use this bottom one. Okay, so let's get that up there for you. So we have cosine 2 theta equals 2 cosine squared theta minus 1. So I'm going to replace cosine 2x with this part here. Now I should have said this before, but if you guys want to try this one on your own, it's really similar to 5. So go ahead, pause me, try it on your own. Okay, so that would be 2 cosine squared x minus 1, and then the rest stays as is. Minus cosine x equals 0. So I'm just going to rearrange that. So I have 2 cosine squared x minus cosine x minus 1. And then I can go ahead and start to factor. So I'm going to move that part over here. So that's going to be 2x squared minus x minus 1. Again, a is greater than 1, so I'm going to have to split my middle term. 2 times -1 is -2. My b value is -1. So I'm thinking what 2 numbers multiply together to get me -2 and add to get me -1. And so that's going to be -2 and +1. So again, my numbers, we're going to split the middle term. So I'm going to do 2x squared. Now split between these, -2x plus 1x minus 1. And then I can factor by grouping. So from 2x squared minus 2x, I can factor out a 2x, and I'm left with x minus 1. I bring down my middle sign. Nothing I can factor out of 1x minus 1, so I can always factor out a 1, and I'm left with x minus 1. So I have 2x plus 1 times x minus 1. I'm going to go ahead and kind of use what I did up here. I'm just going to go ahead and continue to solve first. I don't know why I didn't do this before, but so that gets you -1/2 and +1. And now I can translate that over. So it's going to be cosine x equals -1/2 and cosine x equals 1. And now is when I'm going to the unit circle. So I'm thinking, okay, where does the x value equal? These are both x values. Where does the x value equal -1/2? So looking at my unit circle, that looks like it's at 2 pi over 3 and 4 pi over 3. And then where does the x value equal 1? It looks like it's only at 0. So I have 3 answers. 2 pi over 3, 4 pi over 3, and 0. And that is it. Holy Toledo. Okay. So that's it for the notes. Make sure you guys glue those into your spirals. We will go over any questions that you guys have on Monday, and then we'll go from there. Have a great rest of your day. Have a good weekend, guys, and I will see you on Monday.